Hello everyone. Today we are discuss about different types of starters used for three-phase induction motor, and we are discuss about DOL starter. So what we discuss today, our outlines are introduction, type of three-phase induction motor, why starter is needed to start three-phase induction motor, and our main focus on direct online starter and conclusion. So till now we studied that in induction motor gives us low cost, low maintenance cost, easy of operation, speed variation, high starting torque and durability, or we can say in simple word, that is the three-phase induction motor is cheap as compared to other three-phase induction motor, and its construction and its construction is very good, means the construction is very simple and long lasting. So next we have to discuss about what are the types of three-phase induction motor we have. We have two types of three-phase induction motor, that is one is squirrel cage induction motor and one is wound cage type three-phase induction motor. This section is classified as due to rotor construction, and you can see here in squirrel cage rotor or in squirrel cage induction motor, here end rings are connected, but in case of wound cage rotor or we can say slip ring induction motor, here slip ring are present, and you can say here that is in practical view there is no slip ring are present here in squirrel cage type induction motor, and you also see here that is slip ring induction motor, number of slip rings are present on the rotor side. So why we need a starter to run or to start three-phase induction motor? It means it's some feature like a to limiting some value or by increasing some value. Let's discuss, that is why starter is needed to start three-phase induction motor. For that reason, we just recall a very popular movie, that is a three-idiot movie. That question was how induction motor starts. This is the result and this is the answer. What it is, we need a starter. Let's take an example. Here we are taking here number of balloons and a hand pump, so that our output balloon in this manner. Okay, let's the balloon expanding balloon required x amount of air, total x amount of air for expanding this balloon. If we put that x amount of air directly to the balloon, the balloon will not be sustained. Means we entering that much amount of air by in controlling mode. Means we need a hand pump, and gradually we can increase air so that the balloon will be in expanding mode just like this. Clear? So in electrical three-phase induction motor also, we need or we can supply the starting current to the three-phase induction motor gradually increase. We cannot increase immediately, or we can say in electrical word that is in transiently. For that reason, we are using here one of the starter that is known as DOL starter, that is direct online starter. So what inside in this DOL starter? Let's discuss about internal function of DOL starter. Here we are placing here starter and rotor of squirrel cage induction motor. So we place rotor of squirrel cage induction motor separately, because no need to supply to the rotor side of squirrel cage induction motor, but we can supply to the starter. So here we are supplying three phase supply to the starter, and we can some arrangement from this point to this point, so that we need a thermal overload relay and a fuse section and a magnetizing coil and contactor to keep coil energized, and one switch in NO, that is normally open, and one is normally closed. Here we are using normally open switch as a start button and normally closed switch as a stop button. So what will happen? When supply is given to the three-phase power source to starter of squirrel cage induction motor, the magnetizing coil is connected in this way to another phase. So by placing or by pressing the start button, the connection is here done, so that the current will flow from this side to this side, so that the magnetizing coil is energized. Due to that magnetizing coil energized, the contactor in move to in this direction, so that here this terminal is connected and this terminal is connected and this terminal is connected, also this terminal will be connected. It results that amount of energy from three-phase supply is directly entered to the starter of the three-phase induction motor. It results the starter will run and our induction motor will run, and the contactor is placing here by a spring tension. So what will happen if the excessive current will flow from the three-phase power supply? We don't want to burn our squirrel cage induction motor. We have to stop the power from here. so that we do a special arrangement here. That means the magnetizing coil here, when excessive current or fault current is passing here in three-phase supply, the magnetizing coil will be demagnetized. After demagnetized, the contactor moves back to the original position. That means this will not connected, this will be as a open circuit, this will be also as a open circuit. If open circuit this connection, the amount of energy will not be passing through the starter of three-phase induction motor. Hence, our starter is protected from fault current. So, here we studied that in direct online starter, our starter is or our three-phase induction motor is protected when overload or fault current is passing from the three-phase supply, and also it will start our three-phase induction motor. So we conclude that by increasing the contact current carrying capacity, we can improvise or we can improvise our rated value of DOL starter, so that we can use larger amount of induction motor connected through the DOL starter. Here the image you can see here, the contactors here, 4 number of contactors here, and here is the relay, and that is contact that terminal as you saw in this terminal. This is the 4 section, and here also you can see here in 4 section. Okay.